In our previous video and the other videos, we have shown that how we can compile Petaq service and Petaq implant, and how we can compile and run the Petaq MC bypass patch, how we can use Petaq dropper to introduce the Petaq implant running on Kali to a Windows, which is also up to date and currently running with all features on. That means it's actually monitoring everything in real time. If it identifies anything suspicious but not signatured, it receives some support from cloud services for the signature verification. If the sample is verified, it automatically submits the sample. So simply, nothing is hidden here. And our samples, even used in this exercise, will be used to improve the Windows Defender and MC signatures. So eventually, our samples will be also signatured. So we don't have any concerns about hiding things. Now we need to make things running. First of all, we have an implant. And this implant has started with this command. If you remember the Petaq dropper video, we have used this Petaq service and Petaq implant the way to introduce both of those simply. And now we have this implant, and I'm currently using this implant like this, and I have some features here. I use help, and the help lists all the implant features to me and with some examples. The examples are here, and I can actually summarize them in a nutshell. Exec command can be used to run some certain commands in this Windows environment, but it will be running on the normal shell, normal CMD. So it will be still monitored because there are processes to create and arguments are visible. If there's any tool such as procmon or some other sysinternal tools, sysmon or some EDRs, they will see the arguments. So this is not exactly evading anything. On the other hand, sharp assembly will evade these type of actions because sharp assembly introduces the .NET assemblies in the application process context. It loads them and runs them as is. This helps us to run different .NET implementations in this environment. So the parameters or other stuff, they are not visible to any other tools. Only one thing, which is event tracing for Windows, ETW, is a component used for debugging this type of scripting or assembly services. This can be used to detect our activities. Sysmon, Silk, ETW, or some other EDRs, they monitor this ETW, event tracing for Windows features. Sharp code is also similar, but this time we compile the C# code in memory. Sharp direct is actually a C# shell. You can give some lines and commands and it will compile in memory and it will run them. None of these actions related to .NET touch disk. They run in memory. Even compile actions compiled in memory don't generate any file. That means we don't touch disk. The other things are actually shellcode, and it supports execute shellcode as well using this command. It also supports PowerShell automation. PowerShell automation is used through system management automation. It's not through the PowerShell. If you need direct PowerShell, you can use PowerShell like that. For example, write output. But system automation gives you another harness. In case of other PowerShell features restrict you, PowerShell automation will be less restricted. But still, PowerShell still using system management automation. So don't rely on it too much. This implant also supports some basic actions as well. They are simply linking different implants, running different implants, and uploading file, downloading file, and lateral movement actions such as WMA actions. It also supports some root, sessions, link, and unlink features for the implant management. I will give you a couple of features here to run. For example, exec can run whoami with prev. And that gives us this short list. If we get this done, it simply shows that our user is sheep dev. So our user has limited rights. Actually, that's not exactly true. It is in the administrators group, but it is not elevated. It doesn't use UAC for now. That's why the user does have only limited abilities here. So what we can do here is running some additional Windows commands using exec, like this. Or we can use some other commands in a safer way, just like this one. This is simply C# code, one single line. It uses console write line. That means it writes something to the console, which is test123. So C# works well as well. So what we can run here is actually endless. It's up to us. So we can do a couple of things. For example, this one. First, I'm using temp, and temp is visible to me now. So I can upload some files, I can download some files, and I will upload some of those. For example, our source code files and binaries are here, just like we compiled using MCS in our previous video and Petaq MC videos. So what we can upload is this or this executable, for example. And the path is simply this. So what we can do here is using upload this file, and the file name is, let's say, Petaq dropper, the implant starter, not the implant itself, the starter, and sending this to our temp folder. In this case, our temp folder is visible to us. This is temp, and Petaq dropper will be, let's say, pd.exe. So it uploaded the file. This can be also used for download and other features as well. And we can use almost all of those through this way. So it is available to us. And what we can do with that is slightly endless. And we can even run some shellcode there as well. As we can see through our help, we can give the additional files, .NET assemblies, PowerShell files, or shellcode through a web service. For example, placing those files on a trusted service such as GitHub or Instagram or Twitter, or encoding them and putting there again, such as base60 for encoding. Or you can use file. File means we will upload this file by ourselves through our WebSocket. It won't use any other service. It won't use any additional session. It will use the C2 as the communication channel. This can be used for exfiltration as well, and the entire communication is based on this exfiltration anyway. So what we can do here is using a simple calculation. For example, this one, exec shellcode and file, because we will give a local file to run on the remote side. I will talk about this calculator, but this is a simple shellcode that runs on x64 architecture, and it runs the calculator. See, it works. This simply uses a kind of hidden but also well-known technique by reverse engineers. Hidden technique because it manipulates the process while creating it. So it simply creates a process in suspended mode. It makes the process memory read-write for certain sections, and it pushes the payload given, which is calc payload, which is exec payload, and then making it read execute to run, and then calling a QUI user APC because we added a new thread. So we resume the thread, and the payload will work. This payload can be generated using Metasploit that we will discuss in a later video. Now we have an implant. Implant is here, and everything looks all right for now. What we need to understand here is how we can do some other dangerous things, because currently Windows Defender is watching us and up to date. Implant is running, and Implant doesn't have any issue, but the other third-party applications may have issues. Even though we patch the MC patch only works for our current process and current thread. If we start working with process injections or UAC manipulations or registry attempts or other runtime actions, Windows Defender will identify them through the other monitoring features, other integrations, because MC is almost everywhere. So we need to take some extra precautions. But we need to eventually run, for example, Metasploit, because this is our case, and this is our actual plan. Running all these smoothly, Petaq Implant and service, and then forking also Metasploiter, driven through Metasploit framework for our interactive actions. Let's take a break again, and we will be back with some Metasploit actions.